So please don't be confused with molecular polarity and bond polarity. I think after we finish these exercises, you will have more understanding which is what you need to do to define is it polar molecule or is it not polar molecule. So on bond polarities and molecular shape, they both matter in describing molecular polarity. So what does mean actually when molecular is polar? Molecular is polar when there is no equal dispersion of electrons density here. So one part of molecular has to be more negatively charged because it has to have more greater electron density here. That's why I put delta negative on the left side and delta positive on the right side. So for nonpolar molecule, their electron density is the same in the whole molecule. So there is no charges at all, but in a polar molecule it will be charges. So one part of molecule will have a different charge than the other one. So to define if it's molecule polar or non-polar, first of all, you need to define bonds. So if there are non-polar bonds in the molecule, so of course it will be a non-polar molecule at all. So no charges, no polarity. If there are polar bonds in the molecule, it can be both ways. So molecule can be polar or it can be non-polar. So and we now can discuss how to understand if it's polar or if it's not polar. So you can see carbon dioxide. The first of all, to define bonds polarity, we need to calculate electronegativity difference between them. So carbon has a 2.5 electronegativity level and oxygen 3.5. So the difference is 1. So that means that as greater electronegative atom, carbon has negative charge, and not carbon, oxygen has negative charge on around it, and carbon has partial positive charge. But look at the shape of molecule, or this is a linear structure. So because two electron groups around this carbon repel each other and they stay as far from each other as they could to less repulsion between them. So in this case, this molecule is non-polar because left and right side have the same charge, negative in this case. To be polar, it needs to have positive and negative charge on different sides. So it's non-polar. The next one, ammonia. Ammonia, nitrogen surrounded by 3 hydrogens, and difference in electronegativity shows us that hydrogen has positive charge, partial positive charge, and nitrogen has partial negative charge. So 3 bonds, and they are all polar. But look at the shape. The shape is tetrahedral. The shape of electron groups is tetrahedral, but the shape of molecule is trigonal because nitrogen has a lone pair which push all 3 bonds away. And in this case, we have a polar molecule because around nitrogen there is more negative charge because it's more electron density around this nitrogen here. That's why this molecule is polar. This molecule is polar. So, to summarize, polar bonds does not mean in 100% that you will have um, polar molecule. You can have non-polar molecule with polar bonds in them. Look at the carbon dioxide. And you can have polar molecule or with polar bonds in this. Um, let's do another example. Methane, H4, carbon and hydrogen, 4 bonds here. You can see the difference of electronegativity is small, or 0.4. That gives us 4 non-polar bonds. That automatically means that this molecule is non-polar at all. So the next one, you can see the difference that one hydrogen is substituted for chlorine. So the same amount of bonds here, 4, 1, 2, 3, 4. Bonds between hydrogen and carbons are still non-polar because of the small electronegativity difference between carbon and hydrogen, but the bond between carbon and chlorine is slightly polar because the electronegativity difference is 0.5, so that gives us partial charges. Partial negative on chlorine and partial positive on carbon, and density, electron density goes closer to chlorine. That gives us polar molecule, slightly polar molecule. So you see two molecules with the same shape, is tetrahedral shape, but the first one, methane, it's non-polar because of the same type of non-polar bonds, and the second one was slightly polar. So let's do concept checking. To do this, you need to determine if the molecule is polar or non-polar. So, the first one, what is a central atom? The central atom is nitrogen here. Does it have lone pairs? Yes, it has one central pair, because don't forget that nitrogen is in group number 5, so it has 5 valence electrons here, so one lone pair. Are all bonds identical? And you can see 3 bonds: nitrogen, hydrogen, nitrogen, hydrogen. So yes, all three identical. Polar or non-polar molecule. So yes, it's going to be polar because it has lone pair here, and lone pair push bonds away from it. So molecule, or in a whole, it's polar. So there. Next one, boron trifluoride. So central atom is boron, and look at this case. 3 double bonds surrounds boron, and this is exception. No octet rules here, so boron can be happy or can be stable with only 6 valence electron around it. Yeah, so the electron group number is 3, no lone pairs. Here, all bonds are identical. So, and you can see it's symmetrical. No lone pairs. That gives us a non-polar molecule at all. So, if it if it not be symmetrical, if it will be polar, but in the case it is symmetrical, it's non-polar. So the next one we already discussed, it's CH4. The central atom in methane is carbon. No lone pairs here. All bonds are identical, and you know that, or no, it's I miss. I made a mistake. So it's carbon tetrachloride. So all bonds are identical, but no lone pairs, symmetrical, so non-polar molecule. So, and you can see to be a polar molecule, it needs to have lone pairs. Uh, it needs to have lone pairs. So the next one, CH3 and chlorine, CH3 chlorine, the central atom is carbon. No lone pairs here. And you can see not all bonds are identical, because we discussed that bonds carbon hydrogen are non-polar, but bonds carbon chlorine is polar. That gives us polar molecule. And the last one is carbon dioxide. The central atom is carbon. No lone pairs. All bonds are identical, and we'll discuss its symmetrical non-polar molecule.